for the call. By the way, I hope you guys are aware we always update the playlist after every meeting. So please do to always check them out if you miss something. Please, if someone is asking for the link to the meeting, can you guys kindly share with them?
Ja, das heißt da.
For the tasks, are they? Okay. Where is? Sorry, I'm looking for the right channel. I have lots of channels on my end. Stage one, yeah. So far, how's the internship going? What's your take? Is it too difficult? I mean, at least stage zero. What do you think about stage zero? We'd love feedbacks as well. Kindly give us your opinions. What do you think so far? Recording? Okay. Seems no one wants to give us opinions. Don't worry, it will not affect your promotion. Okay, nobody's interested.
Hi.
Okay, yeah, someone wants to talk. Yeah, I'm listening.
Yeah, the internship has been going good so far. Okay, although the whole internship workspace thing affected a couple of times, but I find it helpful that if you have local R or Python on your laptop, you can just use that while you wait for the internship platform. But the task was very okay, and
Too
I
simple.
think it was, sorry?
Too simple?
No, 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 no. I don't think it was too simple, but I appreciated the fact that there wasn't like one way out of like there wasn't one solution. You could
Oh, yeah.
like use a data structure you liked.
Yeah, yeah.
I did see other people using other options, and
Mhm.
I thought that was really okay.
Mm.
What I have struggled with was the fact that the group was mixed.
Mm.
And in my group, I happened to be the only person using R. Everyone else
Nice.
wanted Python for some reason. So it was just like I was in a team but working alone, if that
I
makes sense.
see.
Yeah.
Yeah, but I think in the end, you guys can also discuss the algorithm, right? The way to solve the problem. No, so that's what we'll do today as well. Either you're using R or Python. I think the process of solving the problem can be the same. It's like saying, I want to eat. The intention is the same in whatever language you use, right? But the way you convey it in different languages is different, right? The way you convey it in English will be different from the way you convey it in French, but the intention is the same. So maybe you guys can communicate on this level, on the level of the algorithm, the recipe for solving the problem.
Okay.
Yeah.
Okay, yeah, it makes sense to look at it that way. Thank you.
Mm. Okay. Any other feedbacks? Stage zero was friendly and welcome. Stage one is kind of scary. Oh yeah, yeah. I believe you, Justina. Uh, yeah, stage zero is unlike Agvi. I'll tell you for that for free. Um, we are never usually this friendly, but then it's a beginner internship. That's why there was at least 3 extra days of extension for a very, very simple task. So yeah. I'm happy we welcomed you. Stage one, I don't think it's too scary. We'll talk about it. And so does anybody have ideas on how to solve the first task? That's the first subtask. Anybody? Anybody with some ideas? So the first one is translate DNA to protein. Any DNA sequence you have, how do you translate it to a protein? Okay, looks like nobody wants to. So it doesn't have to be correct. Yeah, Svetlana has some ideas. Yeah, if else statements. Yeah, Kendra, you can go ahead. It's more like a discussion. I'm not going to give you the solution, sorry. Yeah, Kendra, you can unmute yourself.
Um, I was considering maybe making lists of the codons and their associated I mean the amino acids and their associated proteins.
Mhm. Sorry, probably I didn't get you clearly. I probably didn't get you clearly, Kendra. Can you come again?
Oh, you weren't able to hear me?
Yeah, clearly now.
I haven't fully looked at it, but I guess I just thinking about it right now, maybe creating um lists of the uh different combinations in the proteins
Mm-hmm.
that they or not lists on dictionaries.
Mm-hmm. Yeah, yeah.
Yeah.
Yeah, I think this is a good idea. Setting up a dictionary for any combination of three amino acids, three nucleotides, and whatever they translate to. Yeah, yeah, you can also use if statements. Svetlana, you want to talk about how you can use if else statements? Okay, not talking. Um, so I would like to approach it from how would a human think about this problem, right? First of all, I like to think like a human being because that is what I am. I'm not a computer. Then I can train the computer to think like me or to do it faster, usually. So what I would do if I were the one would be, oh, okay, as a human being, if you were given, let's uh, let's use, I think there used to be whiteboard on Zoom. There used to be whiteboards. Strangely. Oh, okay. I found it. I hope you guys can see my screen. Um, how do you? Okay. Let's say I have this sequence. ATGC, this is here. So if I am, as a human, to break this down into its component amino acids, the first thing I would do would be to split it into three. That is groups of threes. So I'll have this group, the first ATG, and then the second CTG. Sorry, there's no reason for doing this. So the first thing is to split it into threes. And I'll look for, so how would you do this splitting of into threes on Python? That's one step. Then the next thing, okay, let's see, I have this. This is the raw sequence. Now, splitting process. Then the next thing would be, I think someone already suggested it, is to have like a dictionary where you can check it up. Another idea, I think from Melton, was you have a data frame. You can also use a data frame to do your dictionary, basically. So in principle, what you need is some form of method to check the outcome of that DNA to a protein, right? So you can have a dictionary, and the dictionary is basically, I don't know, AUG. So I think you have to also put that in quotes. AUG. I think that's in methionine. Then comma. I'll put a space. I don't know the next amino acid anyways. I think I remember UCA. I think it's stop. Then I'll put stop, right? Then I would, basically what I would do would be, basically what I would do, so I've built this dictionary, build the dictionary. I'm not supposed to be telling you the answer, but then I'm showing you then you build a dictionary, then you check, you go back to check, what does ATG? I mean, ATG should be this. Sorry, I'm mixing RNA and DNA. Then you check, what does ATG mean? ATG means methionine. So you return methionine for the first three. Then the next three, you check it. What does it mean? It means stop. I don't know whether that's what it means. But if it means stop, then you print stop. If it prints serine, you print serine. Yeah. So basically also ensure that your input DNA is in multiple of threes. That is, don't put something like 10 amino acids, put 9, put 12, put 15, put 18, just for a start. Okay. Does it make sense to someone? Is it making sense at all? Okay, yeah, someone said it's UGA. Okay. Okay, Kendra says it makes sense. Yeah, so you could use a dictionary, and like Meltem says, you could also have a data frame, simply a table where you can check it up, right? Any form of system that helps you to go back to like a reference table and check, okay, ATG is methionine, then you can confirm that. Yeah, hopefully it makes sense. We still have about how many more questions to go? 1, 2, 3. Okay, we have 3 more questions. Then let's try and solve others. Stop sharing this. Okay. I mean, the whole thing is recorded, so you can always watch everything back. But if you still have questions, please feel free to drop it. So question 2, write a function that generates a logistic population growth curve. Your function should include 2 extra parameters that randomize the length of the lag phase and the exponential phase. We give an example of a population growth curve. Okay. So GIB is asking a question. Are we going to stop at getting it? Once you convert the DNA to amino acid sequences, that's all. Just, yeah, print it out, right? And no, you don't have to print. It's just a function. We don't need your output. So just ensure the function works. Test it out, please. It's important. Most living populations follow logistic population. Sorry, I'm getting too many notifications. I'll just mute myself. Yeah, I'll focus for now. Okay, so most living populations follow a logistic population. So if you have a microbiologist on your team, I think they should understand this so easily, right? So basically, the way populations grow is that they start. Let me share my screen again. I can delete these. I can clear all my drawings and then I'll draw. If you have a population, the population starts growing gently. That is with minimal effect because there's equal number of growth and death, or probably everybody is not ready to start reproducing. So you have a stable population at some point. Then there is rapid reproduction. And when you reach like the maximum possible carrying capacity of the population, it plateaus. Nobody can reproduce anymore. And at some point, people start dying again. But we would ignore the dying portion for now. So typically, if you are a microbiologist, you know that we call this a lag phase, or if you are an economist, or yeah, I think economists also recognize this. Uh, it's the lag phase. Oh my God. A disclaimer here, my handwriting is way better than this, so don't use this to judge me. And you can use so this place is also exponential phase because there's an exponential increase in the population. And then this place is stationary because population has stopped. Population growth has halted, even though they are not dying. Oh God. Yeah. Anyways, in principle, this x-axis is usually a function of time. It's usually calculated in time, either hour, days, minutes, seconds, up to you. And this is usually a measure or a way to quantify the population density. So I'll just put PD. So I just put PD. So the question now is, how would you simulate this kind of data? Right? So now that you understand how a typical population should grow, now that you understand how a typical population grows, and I think this principle works for not just microorganisms, but probably all living systems. If you have another population growth model, probably you can try it, but we just want you to use this very simple bacterial growth curve, right? It's what many people use. So sometimes the population density can be measured in terms of cell density. If you have like a system for measuring that, some people use optical density, some people use coloniforming units, yeah, etc. So how does anybody have any ideas for simulating this kind of curve? It's like an equation. You can also check it on the internet, but it's a simple equation. I don't know if I'm getting messages. Yeah, okay. Okay, the name is okay. Okay, so do you want to respond? Unmute yourself.
Is it the first order kinetics?
I think first order kinetics is the reverse of this.
For checking the growth of the microorganism such as E. coli?
No, first order kinetics is, I think it's when you are killing the population, when you are administering, for example, an antibiotic, and then you have a negative relationship. I think it's always like this, something like this.
Got it.
Yeah. Yeah, but it's a good try. It's a good try. We should have probably included this as well. Yeah, Munir, Elijah.
This seems like a sigmoid curve.
Yeah, exactly.
So,
Totally a sigmoid curve.
yes,
Some people call it logistic curve, but it's all the same.
yeah.
Yeah, so
So I work too.
mhm.
Yeah.
So you can simply go online and look for the equations for a logistic curve. Sorry, I'm trying to write here, but I think it's very terrible. I think it's a very terrible idea to use your mouse to write. But this is the logistic curve. So if you go to the internet, you can always find the equations for a logistic curve, and you can build the function. If you can build a function for a logistic curve, which is actually very simple. Once you build the function, it's just simple mathematics. It's a fraction, 1 divided by some things. And once you can build that, you can immediately plot this curve over time. Okay, I think someone confused. I feel like I'm scaring someone, but don't be scared. It's actually very easy. One thing I would, I mean, I don't know. It looks straightforward to me, so I'm not trying to downplay the complexity, but you can easily go to the internet, check the function for a logistic curve, convert that into a function in R or in Python, whatever you're using. So let's say this is your function, f of x. We are not going into too many mathematics, just don't be scared. Let's say the function is f. Let me remove the x. Let's say the function is f. Now, the f would accept time, right, as an input for your parameter. So when you are defining a function in Python or in R, you can have some input parameters and say it's accepting x. Then you can generate x over multiple. You can basically loop x. Say you want to change x between 1 to 20, and you want to separate it by ones, that is 1, 2, 3 onto 20. Then you do a for loop that iterates over x 20 times. And then it gives you an answer. And then the answer should give you this kind of curve. Like that is, if you plot x, which is your time, against the answer from this function, it should give you this kind of plot. I hope it makes sense, guys. I feel like I am really pushing you to the edge. Any questions? It makes no sense, or yeah, someone says it makes sense. Okay. So someone says no completely. Can you point me to where you got lost? Someone says yeah, okay. Someone says they didn't really understand the iteration part. Let's look for, let me see if I can share my screen. What's logistic equation? Yeah. Okay. Hold on, stop sharing. I'll share my screen again, not document. Can you guys see my screen? Let's see if I can make it bigger. Oops. Yeah. Can you guys see my screen now? Yeah, okay. So let's say this is your function, right? This is the function actually. So how do you, I believe you can do this in R, or in Python, just arranging the numbers. Now the question is, okay, you can determine the steepness, that is how you want this. Let's see. Okay. So let's say, for example, this is your f of x, like I was saying. You have a population growth curve, and you have L, which is your maximum value if you don't want to exceed some maximum value. Usually I use 1 because is between 0 and 1 or 0 and 100. It's more like a probability of whether it's growing or not growing. That is minimum and global maximum. So I usually use 1. Then you can change this to 1. I mean, this is still 1, sorry, plus e raised to power. That is, e is an exponential value. You will find it on R and Python. It's exponential is a function on R and it's a function on Python. We already probably mentioned it in the functions, but you can find it. Then minus K, it's so if you're using a bacterial model, you can check for the growth rate of bacteria. Say E. coli, you can check for the growth rate of E. coli. Then X is your x-axis, right? So X is what you iterate severally. X is what you change. But for a start, you can say X equals to 0. And your initial X would still be equals to 0. Okay? So because that's your starting point. So initial X value of midpoint. Sorry, I have to be sure. Okay, the midpoint, not the starting, not the initial. Then you can decide what you want to be your midpoint. Say your X, so if you want to simulate over 20 hours, your midpoint can be 10, right? Then you always do the calculation every time. And then, so by doing the calculation every time, I mean, you calculate for X equals to 1, X equals to 2, X equals to 3, until you get to X equals to 20. Now, instead of doing that one by one, you can use a for loop to iterate over that. That's what I meant by iteration. Hopefully it makes sense to someone. So we are not saying you should generate a plot really, but if you know how to plot, you can plot, but you can compress everything into one function. It's also possible. But I wonder if, so the thing again is some of the, so we try to cover everybody's specialization. So I think this is a strongly microbiology and maybe ecology. Maybe people in ecology would also appreciate it. But maybe people in medicine might not, would ask me, why do I need this? But I think there's also, this cancer cells also probably follow this model. They also plateau when there is no longer resources to feed on. They start from an initial 0 population. So it's a general population for most living systems. So it's good to know it, right? It's good to know, it's a good to know concept. And logistic population growth, it's a very important concept in probably all living systems. But there are, if for now it's boring to you, just do it, survive this phase. In the next phase, microbiologists will come and learn from you as well. So don't worry. If that's any consolation. Having 4 phases, so I didn't base my logic. Yeah, up to you. So if you are really good with the mathematics, feel free to break it down. I think there are multiple. There is also Gompets. There is also other series of functions, but I think this is a very simple model and it can just work for you. It can just work for you. In fact, some people would even say they are not even all this k into bracket x minus x naught. They change it to one single thing. And yeah, but up to you. No, ICAM, it's not compulsory to work with a logistic function. Yeah. Okay. I think I also have, yeah, I can also just share from here. So now, yeah, use your function to generate a data frame with 100 growth curves. I think, I remember again. So there are other things that you need to take note while designing this function is we want you, so when you start, it works, right? Once you're able to build it and it works fine. But we want you to change the length. Where's my marker? Wait to annotate. Yeah. We want you to change the length of this place. That is when the population starts growing. That's the lag phase. We want you to be able to change it. We also want you to be able to change when it reaches stationary phase. We just want you to play around with it. See what comes out, basically. See what comes out. We'll probably disable promotions until we are able to discuss the project well. It's just a lot of playing with numbers with this project. And once you get a hang of it, it's going to be so easy. You love playing with it. But for now, we'd love to see what you guys come up with. And if you have a solution already, you can even share and discuss. If you can call for a meeting and discuss with everybody, and we'd love to listen to you. So it's not a competition, right? It's not the first person to finish it. We getting the solution as a whole, right? Yeah, okay, so write a function for determining the time to reach 80% of the maximum growth. So for example, if you have this growth curve, for example, so when does this, so if this is 1, right? If this is 1, 80% of 1 should be 0.8. So let's say this is 0.8. So you just have to write a function. Sorry, I think, okay. So there, you have to write a function for determining another function that is entirely different. So this new function takes in the data you generated, the time against the optical density or the CFU or the population density, and it calculates. So you calculate the time it takes to reach 80%. So if this is your time, we want to know, so if this is your optical density or cell population density, we want to know at what time does it reach 80% of the maximum population growth. I hope this is also cool. A lot of people are going to hate me after this. But yeah, it's a mental exercise. Okay. We are running out of time, so write a function for determining, okay, I talked about that. Finally, write a function for calculating the Hamming distance between your Slack username and your Twitter or X handle. Synthesize one if you don't have one. Sorry, I have a question. I'll quickly look at it. I did not understand what means 100 different growth functions. No, not growth functions, growth curves. So 100 different growth curves. Okay, what I meant by that was that so let me, okay, I'll just look for bacterial growth curve here. Paper that came out recently. Yeah. No, it's not this. It's not this. But maybe they have a sample growth curve. I'm just looking for a random growth curve somewhere. But I know this guy's published something recently. Hold on, I'll get it. I'll get it very soon. I just need to. Oh, sorry. Oh, no, I just found it. Yeah, this one. Yeah, exactly. Looking for, actually, some of you are going to work on data sets from here. Yeah, so this is what I mean. So if you look at this growth curve, for example, or some of these growth curves, you will see, for example, this EC, is there a way to zoom this better? Yeah, so let's look at these, for example. This is a simple growth curve model, but you will realize that they have different lag times. That is the time they start or the time they switch into exponential phase. I know people that are not in microbiology are going to hate this, but please, or people in microbiology and biochemistry will probably appreciate. I'm also a microbiologist, and I'm happy that I'm oppressing you. But yeah, basically, what we want is find a way to also be able to simulate changes in the length of the lag phase between two different conditions. So basically, you are simulating, for example, antibiotic treatment, or you are simulating disaster in a population. So the population is unable to start growing immediately. That's the consequence of what you are doing. I don't know if it makes sense. Yes, relative, exactly, relative, exactly. You get the point. You get the point, Svetlana. So it means different positions of graph paths, one relatively to another, or different. No, it's not different curve forms. I would say different position relative to one another. Yes, but you don't need to generate the plot outrightly. If you can generate the plot, fine, because probably you've seen the solution. You've went to study plots, the plotting part or the visualization part. But if you're unable to, it's completely fine. You don't need to generate the plots for now. Yeah, 100 possible conditions. It's very easy. You just need to change 2 parameters and you are good. Yeah, I believe you guys understand now. Sorry, I was supposed to clean this and yep. Okay, my battery is low. I'll quickly charge my device. You can generate a plot for your personal, how do I say? You can generate a plot for your personal conviction or visualization. We don't need it for grading. That's what I mean. That's the answer to Samuel's question. So I'll try. So please remind me to always read the question so that people who are watching can understand the context of the question. So if we don't generate the plot, how do we know what the function will? How do we know that the function will work? So we don't need the plot for our own for grading. That's what I mean. You can use it for your own. How do I say? For your own conviction, because humans are visual beings, so you need to see. So Svetlana says, so it is a kind of iteration. Yes. Yes, you are going to use your for loops hard this time around. Yeah. Okay, I'll quickly go to the last question. Write a function for calculating the Hamming distance between your Slack username and Twitter handle. So if you don't use Twitter, it's fine. We just need some form of other username or that you use. Maybe it's even your email, right? Compared to your Slack username. It doesn't also have to be your Slack username. We just need 2 variants of usernames that you've used in the past. I think for someone like me, I've had a consistent username for over multiple years now. So maybe it might be hard to find, but you could just switch something between 2 different variants of your name. You can use your name and your alias or your what your friends call you. So then feel free to pad it with extra words because the Hamming distance is based on the premise that they are equal distances. That I mean they are equal length, equal in length. So now your task is to calculate the Hamming distance. Does anybody have any ideas on this? Any opinions or suggestions? Okay, nobody has basically is yeah, exactly. Try to find out the number of different characters. Exactly. Yeah, it's a so it comes as it's a square alignment. I think that's a complicated way of solving a simple question. So in principle, you are just looking for the number of things that are different in both cases. It's usually the foundation of the foundational, how do I say? It's like how many of the alignment techniques started out. It's like the foundation of how the alignment techniques started out. So try to, if you know it, if you're able to really solve it, it helps you to build a foundation for much more complex things in bioinformatics. So Docker says, I don't even know what Hamming distance means. That's why we explained it just now. Hamming distance is basically trying to find the difference between two characters. Okay, I'll make a simple illustration as well. So I'll clear everything. Let's say you have the words, so let's say my name is Joseph, okay? Probably you see me on LinkedIn. So let's say Joseph is my Twitter handle. And then my Slack handle is Josoga. I don't know if they have the same length. So 1, 2, 3, 4, 5, 6. They are both 6, right? So in principle, you can just delete. They are equal. So it's 0 still. O and O are equal, so you can delete. S and S are equal, you can delete. O and E, they are not equal, so I say 1. P and H, they are not, P and G, they are not equal, I say 2. And H and A are not equal, so I say 3. So the Hamming distance in this case is 3. So how do you solve this on code? That's what we requested for. If you have numeric characters, yeah, put it. We just want to measure how different they are from each other. Asking for a friend indeed. Yeah, so the question was, what if our Slack usernames and our Twitter differ by numeric characters? Do we include them as well? Yeah, please include them. And she said she was asking for a friend, but yeah, I do understand. I know the friend. So Svetlana says using loop. Yeah, you have to use loops in this case. And Docker says if and else. I think you also have to use if and else statement. Yeah. Because if it is the same, you count 0. If it is different, you count +1. But then you have to loop over all the indexes, all the positions in this simple what do you say? In your numbers or in your characters, sorry. But I think everybody understands it now. That's why we said if they have different lengths, add it with something. Add something extra to make sure they are equal lengths. Yeah. Okay. looks like everybody is happy, and to some extent, they understand. You don't have to start with the hardest one. You can pick the easier ones and start solving. If you come into any challenge, feel free to ask. Mostly on the help channel and on Nucleus, but you can't ask on Nucleus because you can't even type there. Yeah, so Docker says, what if there is no similarity between both variants? What would be what would be your answer? I think it's straightforward. If you have 7 characters on both sides and there is no similarity, then your Hamming distance is 7 because nothing is similar. Okay. Any other question? Yeah, I think it is important. It is good if you so Ecam is saying for each goal, it is obligatory to create only one function. So here's the thing. I'm specifying your name and the question because we also put it on the internet, and it makes sense for people who would watch this later on to be able to follow what we are discussing. So if you don't want me to pronounce your name, it's fine. So for each goal, it is obligatory to create only one function. Yeah, I think so, because the internship manager is looking for 4 functions. Yeah, and we have just 4. Is the third question independent of the second? Yeah, they are completely independent of each other. So Justina says we are to find the Hamming distance. It's not hammering. Hamming distance for everyone's name. No, not everyone's name in the team. It's your own name. Okay. You mean for your own test while you are learning, create for your name and for your username or for your Twitter handle name, something. So basically, the point is not just we are just using your names and your usernames and your handles to test the function that you created, right? It's not for you to learn, pick your own names, right? And just play around with it. And if you know other people's usernames, just play around with them as well. Please, I didn't really get what you explained about the second question. After getting the function for the logistic curve, what are we supposed to do? Use it to generate 100 different growth curves. I think you can also watch the video once again, and you can catch up. But I try to also provide illustrations, so maybe it can help. But then still, if you don't get it, come back and ask on help. It's fine. Okay. So far, was the meeting productive for you, or you are scared more? And don't worry, this was not from NASA. It's just, I think the NASA questions will come from next and upper week. Okay, it's helpful, but it makes you scared. Okay, not bad. Okay, I don't know the emojis. I don't know what they mean. But I would mean, so Google says smiling. So that means you guys are happy. Yeah, okay.
I have one technical question about the GitHub.
Okay.
So I was not able to set up the GitHub last week, but I'm trying to do it right now. Will it be, I mean, is there a repository for the entire internship, or do we
No,
have to
it's your
create?
personal. It's personal. Because in the end of the day, the codes are yours. It's not ours. So keep the codes to yourself.
Okay.
And yeah,
And then we can find the people from this internship in GitHub, right? If we have to submit.
up to you. You can ask for people. You can go to random and ask for people to share their GitHub profiles with you.
Okay.
Yeah.
Makes sense. Thank you.
You're welcome. So there's a lot of sign on the chats. Why are you guys scared? So in principle, you can leave. I'll stop recording now. Except I have interesting questions. I'll stop all this. When submitting, can I create a project as script plus library that has 4 functions? Yeah, it should be one single script and everything, all the functions should be there, but don't use libraries. I think I should mention that. Don't use external libraries. Everything has to be coded raw. Don't import anything. Yeah, please don't import anything. The point is that you're able to solve the tasks. If you need, okay, yeah. So if you need assistance, please reach out. Randomly also request for calls, depending on how my time is as well, and maybe if I have the feeling that a lot of people are unable to solve it, or it's just creating a mess, we can probably do a live coding session. But I'm not promising that. Are we doing this work individually or maintaining our group? If you're in a group, you can feel free to work with your group. If you want to work individually, tell your group and just leave them alone. Up to you. Because because there's Uracil instead of Timidin, I would say you can move from Timidin since you know it's T, you can move directly to you can move directly to your protein or your amino acid. But if you really are a scientist, a hardcore scientist, you really want to fulfill the laws of biology, feel free to convert all your timidins to uracil, and from there you proceed. But I don't think you need a special dictionary because the only thing that is changing is timing, not all the sequences. Is the deadline of February 15th? 16th. I think we didn't put the deadline yet. Yeah, we are still thinking about the deadline, but yeah, let's use 16th for now. The deadline should be 16th. I don't know if Abdurrahman is asking a question, but probably he's trying to explain to Muniro that the nucleotide codons is multiple of 3 nucleotides. Ikam is saying, does the third function retrieve the information from the second function? No. So they are not connected. It's just an independent function. But you can test function 3 on the outputs from function 2. That's the beauty of it. Yeah, that's just the beauty. All right. I think we are done for today. I'll stop